koutou katoa. Thank you all for having me and turning up to lovely breakout room and hearing me ramble on about the wonders of Python in education. This does involve audience participation. I know it's nearly midday, so hopefully the coffee's kicked in and you do have a little bit more energy. But to start things off, who has been in high school in the past, like, let's say 10 years? Put your hand up. Oh. Perfect. Who has done NCA digitech? I see you love it. Yeah, that's the topic of this talk. Yeah, I know. I kind of invited you in with better grades. No, we're talking about school. We're talking about this wonderful thing called manual testing tables. Many pages. We're talking about Java because we like types. We're talking about online tools to automatically do formatting and linting because why would we set this up locally? And we're talking about why we should build GUIs and Tkinter without teaching classes because that sounds like a really easy thing to do. So why are we here? I'm with a charity called Tūhura Tech. We operate across Greater Wellington. We do digital technology education pretty much from year 13 all the way down to year 5. We're everywhere. We do it all for free. And we pretty much do everything tech, which means that we're kind of qualified to talk about this in different aspects. For me, I'm biased. I founded the charity, so yeah. I also have a decent amount of industry experience leading global teams in fintech because I love money. And outside of that, I play around with a whole bunch of different things. I do a surprising amount of hacking for someone who does not do pen testing for a day job. And I love dance, so I can see a whole bunch of other tech people in here who also do dance, which is always great to see. So let's talk about digitech. Let's talk about NCA. NCA, for those of you who don't know it, has standards. We've got level 2 and level 3, which is year 12 and year 13. I'm ignoring level 1 because it makes life painful. The standards are really nice. I say this because they don't really say anything. They leave it all up to the teachers, which is this amazing idea. So level 2, we need linked data in a database. We need some basic logical operators. Level 3, cool, we need to structure it a bit more and maybe display it through a web page. This all sounds relatively easy. So let's put some Python into this. Let's make this a bit more fun and let's see how you can actually deliver this and why this is relevant to you. Let's talk about testing. Who here likes testing? Writing test cases. Beautiful, cool. So let's write some tests. In NCA, we need to write tests. And by that, it means we need to write test plans on paper to document with images the manual testing that we did. Because we really like tests. They had to put a limit in of about 5 pages of like small size 11 font because people were doing too many tests. Let's just say that students love this and teachers love marking this so much. That is complete sarcasm. So let's make this so much better. Have any of you used PyTest or unit test or Tox or Nox or any of the other fun things? They're great, right? We can write automated tests. We can run them again quickly. It does not take an entire another day to write tests. And we get coverage as a percentage. It also means that when we submit our assignment, that test that we fixed a week ago, that we didn't run because we thought we fixed it and is now broken, means our grade goes from excellent down to a merit because our testing was wrong. So we've got all these schools, we do this great thing. We need to start looking at automated testing. This is not a hard thing to teach. It's surprisingly easy. We write Python code to test Python code. It's great. PyTest is really nice to use, a little nicer than unit tests, but that's personal opinion. You can have a long chat to me about this afterwards if you want to go into pedantic details. But we've got all these lovely testing programs. We can start going deeper into them, and then we'll start teaching them in a school context. Funnily enough, when you come out of school, you don't hate tests. You, maybe not so much of a fan, but you want to write tests and you see the merits of them. And when we start bringing this industry practice of, cool, what is 80% test coverage? Okay, technically you can do 100% test coverage in schools, simple programs, but there are edge cases to that. But let's start bringing in these industry ideas of, let's do fully automated tests. Let's introduce coverage. So we've got full path coverage for all our weird and wacky inputs, because I know we checked if your age is above 100. What happens if your age is negative 30? What happens? It means that my lovely tool that tests how old you are or what year you were born, I can be born in the future. It's great. But we can check those things with automated tests, because automated tests are so smart, and the tools are great. So it's starting to bring these industry things in and start teaching it at a school level. So let's talk about types. This follows on really nicely from the talk we just had in here. We've had the explanation of what Python types are. In school, do you know how we teach types? We teach C, or we teach Java. It's beautiful. But guess what? Python has these. Python has types. We've had them since 2014, all the way back in 3.5. They didn't look as nice as they do now, but we've had them for a while. And if we take a look at the code, we've got on the left-hand side, we've got a normal Flask application. It works. On the right, we've got a normal Flask application with types. This means that we know that what's coming into our hello function is going to actually be a string, which means if we want to start doing really different things with it, we can start playing around a lot more, and we can start going further deep into it. And this is actually easier to teach in a school, because the really nice thing with Python is you don't need this. You've all written your quick hacky scripts without types. You've all written your massive legacy enterprise applications without types. And then you can introduce them later. Or not. That's up to you. Because they're relatively easy to use. You've got tools like MyPy, which is really friendly. There's a slight asterisk there to some really fun edge cases that either I have encountered or other people have encountered. It's great until you start getting to complex things. But the really nice thing is schools and kids don't encounter these. And when a kid does encounter this really weird, obscure edge case, they're not actually put off by it. They want to then work out why and then fix it. And now you have someone who's contributing to the MyPy code going, this doesn't work, can I fix this? But the point at which you've got kids with boundless energy, way too much free time, and they don't like being told no. It's very much a, here's why, let's fix this. So you very much want to, with types, start going in and start bringing these industry concepts and bring them in. And then you've got things like Pydantic, if you've ever played around with that, which is pretty much data classes on steroids with a whole bunch of validation brought in, which you can then start combining with tools like Fast API and all your fun, big, enterprisey libraries. And if you've used them before, they're not hard. They're really not much more complex than a Flask app. A Flask app versus a Fast API app is pretty much the same code, slightly different. You've got a bit more classes, as in Fast API really doesn't like it if you don't have classes. But you're starting to bring these concepts in from industry, that these are these very enterprisey concepts. These are these things we have to do in industry to make a secure app. And we can just put this in education. Why are we waiting until you enter industry, you've gone through your primary, intermediate, secondary, really it's intermediate for Python, hopefully, fingers crossed, we still have Scratch in many places in level 3, and university, and then you're going like, oh, here's types. Let's force this in. Let's re-educate you on everything because we haven't done it earlier. Let's bring this in earlier. It's not a hard concept for a kid. I say, because we've taught the C of 5 and 6s, which are 8 and 9-year-olds, they surprisingly got it. And then they went really far, and we had to play catch up, which is really fun. It's great when kids go really far beyond you. Do any of you know what PEP 8 and PEP 257 are? One of them? Cool. Don't you love them? They're so easy to understand. It's this lovely document. It's really well written, but it's this really long document where you've got to go like, cool, here's how you name variables, here's how you order imports, though that's more left up to interpretation. Here's how you do doc strings. And these are all things you've got to do in industry. You've got to, if you want clean, readable code, you need docstring. You need that ID integration where you can hover over it with IntelliSense and go, cool, what does my magical make lots of money function do? Does it actually make money, or does it just put a crypto miner on my computer? We've had kids do that. It's interesting. Welcome to introducing sandboxing to your assessments. You've got that. So how do we do it in schools? We've got these really awesome online tools that have been built down at the University of Canterbury. There's one thing. They're all online, and they're limited in what they can do. They're great. They're amazing. They're available. But do you know a really interesting thing about me? I'm really lazy, and kids are also lazy. So why on earth would I do it online or by hand? We've got MyPy, we've got Rough, we've also got Black and iSort and Flake8 and a million other tools. I'm choosing these two because I like them. But you've got them. They're formatters. They're linters. You can then start to combine Sphinx with your auto-generation of documentation. So now your 40-page report that you handed into your level 3 internal is now, well, you've auto-documented your API endpoints. You've auto-tested your API endpoints. You maybe even done some front-end testing with Playwright as well, so you've introduced automated testing, so you've gone further. And when life just gets so much easier. And what we've got is these really big, scary enterprise topics. This idea of we want to auto-fix things. We want to go through and automatically clean up a ton of code. We want to catch our security bugs. What is a security bug? Why shouldn't we hard code credentials in our file? Why? Because then we teach the kids cybersecurity right after we teach them how to build apps. And we deploy those apps live. And we get them to hack it. Really fun. If you ever hacked your friend's website, first off, ask consent. Legal, New Zealand law, quite clear on that. But it's really fun when they hard code all their credentials, especially secret or dev as their encryption keys. But we need to teach this at a younger level. We need to start teaching this at high school. We need to teach this when we're actually introducing this concept rather than you go to industry and then the lovely InfoSec person comes by after they've just run a SIMGREP scan of your code and gone, hey, why have you hard coded our database tokens in the front end as a comment that's not auto-minified? I've seen that. It's great. I've seen that live, actually, on a website. But we've got all these things and all these considerations from industry. And a lot of the assumption is that industry, we need to be special. We need to make sure we do things perfectly. And this is very unique to us in industry, whether it's fintech, because you've got money, or you're doing government and data compliance, or you're going into different areas, and you've got all these tools which have amazing developer experience built into them. We can bring these in. Flake8 is not a complex tool. Okay, once you start building custom rules, very complex. But once you're starting actually to implement it, it gives really helpful errors. And these really helpful errors will be really nice to provide to kids right at the start. Because if you can automatically tell someone that your code doesn't work because you've not used the variable you created at the top, because, well, you've got a whole bunch down and it won't have your IDE window now, so you forgot about it. If your tool can tell you that, do you know how much time that saves you? And you're assessed on this. And we don't like being assessed on things that we then have to write answers on. So what? Why do you care? Why are you the people in industry who are not teaching, or you've escaped high school, you've escaped the confines of doing NCA assessments? Or so you think. Welcome to certifications in industry. It gets better. Why is this relevant to you? Why is this something that I'm coming to a Python talk to talk about rather than talking about this at a teachers conference? One, because I do enough talks at teachers conferences already, and that's a whole experience. And two, you're the people in industry. You're the people who are using these tools day to day. You're the ones who decided that you really disliked the fact that Python didn't give good error messages. So then in Python 3.12, and I might be wrong on that, decided to rewrite how all of Python does error messages. So it can actually tell you what line your code is wrong on. Rather than it being the line before, which you forgot a bracket, you've actually fixed these things in industry. Does this annoys you? Does it annoys me? And if it annoys me, it absolutely annoys you. You're the ones who have built tools like Rough, or you've gone in and built Black, and you've built iSort, you've built Sphinx because you build a ton of libraries. And suddenly, you've got people who use your libraries. And you don't like providing support to random people on the internet who ask you, how do I import your library? So you write documentation, but we're also lazy, so we auto-generate the documentation from our amazingly written doc strings that our tool told us to write properly, because we didn't really want to write them in the first place. So we put in a tool to make us do that. And then with these tools that we've built to make us do things properly in industry, they've made our lives in industry so much better that would count as industry tools. They aren't industry tools. They're just tools for Python in general. And you've got the fun people who are doing programming in Python who are also stuck doing this. It's the same thing. So I've got a whole bunch of really fun anecdotes. These are the things I want to put in my talk, but are going to end up going down rabbit holes, and we'll talk about them really briefly. If any of you saw the blog post a couple of days ago, we've got Python packaging. I'm not going to have a talk about Python packaging because we'll be here a while. But you've got Rye, Poetry, PDM, Pip Tool, Pip, all the fun Pip and stuff. And you've got UV. Currently, in schools, we do this lovely thing called REPL.it. Or, yeah, that's it, REPL.it. Or maybe some of our online tools. We've got all these things. We don't do packaging. It's this really complex topic. But once we start simplifying in an industry, like things that UV, which was released by Astral like 2 days ago in a blog post as feature complete, with a whole bunch of asterisks on that, looks super promising, where we can start to automate a lot of what we're doing. And once we start automating things in industry, we can start to then apply that out to wider areas, start going into education. We've got CI/CD. How many of you like writing CI/CD pipelines? Oh, there's more hands than I expected. Who thinks they're simple? That is one more hand than I expected. They're not. They're really not simple. But you know what the really amazing thing about CI/CD is? It's the same everywhere. Your CI/CD setup that runs PyTest is the same whether you're on a 200,000 line monorepo and a 3-file Flask app for your NCA internal. We can start bringing a lot of these tools in. We can start going, hey, we've got all these amazing setups. Let's start bringing this into schools. Let's start talking to teachers and kids and going, cool, you've got a project. We know you have to do it in version control, so we've had to teach you Git, which is an experience. And let's just give you a template. Let's give you a working CI/CD template, which means that your code, when you commit it, is automatically going to be tested. And what this means is when you then turn around and submit your report 5 minutes after the deadline, because, well, you had better things to do, it doesn't have a bunch of typos in it from that fix that you pushed from your phone before pushing the code. It was tested up in your repo. These are not new ideas. Like, nothing new here is new or revolutionary. It's all things that we've had for a while that we're starting to bring in. Also, deploying student projects is awesome. If you've ever worked on a personal project, or you've had to do a workshop or training, it's like, cool, you're doing this, and then there's nothing that comes out of it. Isn't it so much better when you get to see what you've built and it gets deployed? Student projects, yeah, they're insecure. Yeah, they don't work half the time. But deploy them. It's cool. Who cares? Put a resource limit on it. They're not really going to break anything. And suddenly you've got all these awesome student projects that you've got sitting up on the internet, both either in Git repos for students to share and talk about, because that's their portfolios when they come into industry, or just show their friends. And it's making these things more accessible. Because this all looks really scary. all of these massive enterprisey tools look scary because you've got a lot of details on them. And all the people talking about them are people who decide to have a long Hacker News post about this and discuss the merits, which looks really terrifying. But it's not. It's relatively friendly. So you should get involved. Now, I'm biased. You should volunteer with us. Yeah, I'm biased, I know. Also, if you have money, we're a charity. Sponsor us. I have to put this in. My board will literally kill me if I do not. They will be watching this recording. Hi. Otherwise, you've got a bunch of other organizations across the country. You've got Code Club, which is free volunteers. You're all in industry. You can all talk to people. You're here. You're at a conference. Therefore, you can talk to people. So don't pretend you can't. Which means you have social skills. Which means you can spare an hour a week, or more than that, an hour a month to turn up to a Code Club at your local store, your local library. Because you're the people with experience. You're the people who all these kids are looking up to. You're the people who know what's actually done in industry. You're not stuck teaching where you're isolated from everything else that's going on. You're actually working on it day to day. Go and run a code club. Reach out to your local school. Yes, they will police vet you. No, it is not a scary process. It's a 2-page form. They don't really get much information out. They do not get your parking tickets. Do not worry. Reach out to them. They'd love for you to come in and give a talk or run a workshop because you've all got experience. You've all got experience that's super valuable because you do this for a living, or you're a uni student who has spent way too much time on these really crazy projects. They've either worked or not. Let's be honest, they haven't worked. We've all been there. And coming into those schools, because this is the generation that's going to be replacing you in all honesty. They're going to be the people who take your jobs eventually. This isn't the AI taking it. This is just humanity. They're going to be the people who come in and do this. They're going to be the people who are coming in to work on the next application that you're going to be using. They're going to be building the next everything. So pretty much get involved with them. Get involved with them at the school. They're not scary. Yeah, okay, kids can be blunt. But they're not really good. They're not that scary. If anything, they're afraid of you. You're terrifying. You're an adult who has a job and a life, which is actually for most kids terrifying because you appear like organized and you appear that you know what's going on. They don't know the truth. We're never going to tell them, but that's what you've got. And if you bring all these tools that you've got from industry in, and you bring these into schools, you bring these into, you introduce your kids to them if you've got kids, or you introduce the kids who come and ask you random questions about this really weird thing they want to work on, because they want to build a Swift compiler in Rust, because you said something stupid to them, but it's hard. These are the people you want to talk to, and these are the ideas you want to give them. Don't go that this is what industry's got, and this needs to stay in industry. This is what needs to be brought into education right at the start. This needs to be brought in right from our starting conversations. So that's all I've got for you. We've got time for questions. There's also details of the charity. If you email the contact email, it comes to me anyway. Otherwise, you can get contact details off me after this. But otherwise, we're open for questions, if you've got any.
Do you have an opinion about using doc test? We actually put the unit tests in the doc string, and then when you auto-generate the documentation, the tests become examples.
Yes. If you teach it, and you teach it consistently, and you've introduced it to kids, then it works, in all honesty. Like, I'm not going to say that the tools I've introduced up here are the holy grail of what you have to use. They're not. They're just the tools that I decided to put on here because I like them. And those are what I personally use in my projects, and it's what we use for teaching when we're going out to all the different schools across the region. Doesn't mean they're the best? No. Could I be missing some? Absolutely. But if it works, and you use it in industry, teach it to kids. It's the same principles. Like, how whatever you're doing, it's the same principles that apply. It's the reason why we can teach Python as a first programming language, and then go to everything else. It doesn't mean they're stuck on Python. They can transfer this knowledge.
Hi, I have a 9-year-old who's quite into programming and loves that mom's a programmer. When you're talking about 9-year-olds, it's like, oh my god, that is mine. But the problem that I have with it, like, he loves when I go into a school and talk about programming and stuff like that, but I always struggle figuring out sort of the appropriate size and scope of the thing to work through. Like, do you have any tips for approaching that?
Yes. It differs person to person, so I'm going to give you general advice. I can have a chat to you after you want really specific. If you've got kids, Scratch is your perfect introduction. That, I will say, is the holy grail of introduction to programming. And I will fight you on that. Scratch is awesome. I love it. It's incredible. If they've done Scratch and they've started to play with variables and my blocks, they've basically just learned functions in every other programming language. Then it's a conversation of, cool, do you like game dev? Cool, let's teach you Godot, because Godot is awesome and quite approachable. You like building websites? Build HTML and CSS. Start small and just let them explore. The job for kids is, cool, here's what you've got. You're going to go and explore this yourself. We're going to support you, but the kids are just going to naturally go out. They're going to try a million things. They're going to break pretty much everything you throw in front of them. But you want them to do that, because that means they learn. And that's how we learn. Even in industry, and we go like, cool, we don't break anything. Yeah, you do. It's called writing code. It's called testing it locally. Yeah, for kids it looks a little bigger, but that's how you learn. That's how we start. So it's very much start with Scratch and then go based on what they're interested on, or get them along to a local code club where there'll be other people they can talk to, and suddenly their world opens up massively.
You spoke earlier about trying to move to running some of the tools locally rather than. How do you cope with this plethora of BYOD? You know, some people on Chromebooks, some people Macs, some Windows. How do you cope with, like, the schools seem to be moving more and more to, when I talk to my girls' college, they said, "Oh, we do everything on this website because all of the executions remote, it works on web browser from whatever they've got."
Yes. I'm going to say something slightly controversial. Chromebooks are horrendous. Like, on websites, it works. It's easy for a school from an infrastructure standpoint. That's where they do it. It's consistent. But we're teaching digitech. We're teaching programming. You can install it locally. Like, installing Python on your local computer is not hard. Whether you are running Linux, yes, we've got a bunch of kids running Linux. Whether you're running Mac, whether you're running Windows, it all just works now. And your tools just work. So it's not that hard to get them introduced. It's your first lesson you spend introducing tools into your computer. It's something that should be done locally, but you're going to end up doing it locally. And on a website, it's going to be a subset that's going to limit you with what you can do.
As well as teaching children about how this works, can you do much in terms of teaching teachers how to teach to their standards as well?
Yes. I haven't touched on what we do specifically as a charity. We run after school sessions for kids. We run during school sessions for kids. We help run all the competitions for kids, both nationally and some of the big overseas ones. We also run workshops and training for teachers. We build resources for teachers. Everything we do is in the Creative Commons. Yes, absolutely. And even as someone in industry, just talk to your local teacher. Like, reach out to your local school and ask them if they want help when they've got questions. Teachers have no time. They are super stressed and super they don't have time to learn these new things and keep up to date. The reason schools still teach PHP is not because the teacher doesn't want to move off it, so they don't have time to move off it. They don't have the support. So reach out and help them, because they'd love to go and talk to industry. Anyone on this side that has questions?
We have time for one more.
Yes.
Sometimes with learning, you want people to do something manually, even if it's difficult or time-consuming. Are there many times when you would try and stop someone using a tool that might make their life easier just for learning?
Yeah. So all the tools I've brought up here, I will never introduce them to deck on day one. I'll go like, cool, we've got Pepe. This is how we do formatting for the first half an hour in the first session. After that, they understand the concept. Have you ever manually gone through code and formatted it according to Pepe specifications? No, because that's super time consuming, it's super tedious, you're gonna get it wrong anyway. Use a tool. Like, you introduce these concepts, you introduce them manually. Like, you introduce testing, you introduce them what a test framework is, and you go, cool, you can do this manually, or you can use PyTest. So you teach the concept, and you do teach that always manually because it's not gonna work otherwise, but then you teach them to the tools. It's not just, we're gonna do it manually because this is how I taught it initially. It's, this is the manual, and then we're going to use the tools, because the tools require you to understand it. They aren't just magical, until sometimes they are, but yeah. But thank you all for coming. Come chat to me afterwards.